Today, we have a quick wrap up about our brand new car train. At my side, Daniel, it's great to have you here.
To be back.
This is our brand new car train diagnosis and repair of high voltage vehicles. What do we see here on the surface? Just give us a quick rundown what we have here.
So if you have a look at the system here, we've got a number of gray boxes all over, plus a vehicle. These are all the different systems that we see on a high voltage vehicle. So important that we say high voltage vehicle, not EV, not hybrid, because we're able to emulate 5 different types of vehicle drive systems. So electric, parallel hybrid, series parallel, or fuel cell vehicles. So we're able to do that all on this system without the use of overlay masks. But first of all, we see here our driver interface. So we can see how the virtual cockpit, we're able to go through and see what are the energy flows during different drive modes. In the background of this system is a mathematical model of the various types of vehicles that we created so that we can actually create real energy flows here. Obviously, when we see the vehicle right here, we've got the drive of the vehicle, but we've also got the various access points for first responders. So the first responder cutting loop or the first responder high voltage fuse, where you're able to pull it out and the system will shut down. The green connector here is more for technicians as the low voltage service disconnect. And so they're able to, as part of the shutdown procedure, use that. We have our smart key here as well, which is an integral part of isolating the vehicle. Obviously, the smart key needs to get put into the safety box when we're shutting down as well. If we have a look now at the various components that we have here. So this side here is our high voltage battery. So the high voltage battery then is made up of the various modules of the battery. So we can see here we've got a 400 volt battery. With our manual service disconnect right at the bottom here. So that's keeping the 2 modules connected. If we remove the manual service disconnect, we've got then 2 modules of 200 volts each. Above that is our high voltage relay assembly. So this is where many different names, contactors, system main relays, but these are the relays that are switching the battery through to the rest of the vehicle. So we can come up here, we can see the LEDs are giving us the control of those relays, or we can measure those here as well, which is a great project that we can do with it with an oscilloscope. We can see the process of those relays switching on and off. We can see here also our current clamp that is measuring the current either going out of or into the battery. So obviously during regeneration that we can see here, we'll have current going back into the battery. There's no real batteries on the system. It's completely digital in that we're able to simulate or emulate the various vehicle types. So there's no need for real batteries to be charged or maintained. Coming up to here is the onboard charger. There's 2 different types of charging inputs that we see now. This one is the type 2. That we see. There's also a type 1, different models available for the different types, different parts of the world. But we can see here, this is our onboard charger. So using our EVSE, electric vehicle supply equipment, which is where the cable comes from out of the socket, into here, where that's being rectified, and into DC, which is then able to charge our battery. Obviously, when the vehicle's shut down, you can plug that into or plug a normal charger into that, or the charger that we can supply as well. If we come across now, we can see here we're still in the DC range. So we've got our high voltage battery is a DC power source. If we come across here, we can see here energy flowing from the battery over DC. So we've got a positive and negative. We come to our power electronics. So the power electronics is otherwise sometimes known as the inverter. Few different names. The inverter is the general term for the complete assembly, otherwise known as the power electronics. But the inverter is what converts the DC into 3-phase AC. So we see the 3 phases coming along here into our motor generator. So that's what's driving the vehicle. And if we go back into regeneration, the regeneration is also occurring from this section here. We can also simulate that with braking. So I'll just let it get up to speed. Press the brake, the system actually slows down, brakes on its own, comes to a stop. All of which, because of the mathematical model in the background, can be measured at the amp clamp that you measure over here as well. We can also see that we've got a ammeter on the AC side. So on this, the difference between that one, we're seeing a DC signal on that side. What is the current? Here we're going to see that if you hook that up to an oscilloscope, you'll actually see the sine wave that's being produced through the motor generator. So an inverter is going to create pulse width modulated signals, a digital sine wave in the end. But once the current runs through the windings of the motor, the current will be in an AC, and that's what we can measure here with that amp meter. Coming back to our inverter here, we can see that we've got 3 fuses inside of our high voltage distribution. So we've got essentially a bus bar there with 3 fuses that go along supplying current to our consumers, such as the heating, PTC heater, or the high voltage air compressor, and the DC to DC converter, which is simulating our alternator that you would have on a combustion engine, a conventional engine or conventional vehicle. This system, this cover here, has a double purpose. Underneath here is our high voltage inspection point. So when you're doing an isolation, a shutdown of the system, there's 2 points up here that you need to measure as a part of the live dead live testing. So live dead live testing is where you're measuring, for example, on our 12 volt battery down here. So to measure that our multimeter is working correctly, come up to here to measure our high voltage system to make sure it's free of voltage at 0 volts. And then you go back down to your 12 volt battery again to make sure that your meter is still working. So 12 volt battery, also with a real emulation behind that as well. We can emulate the battery being flat, needing a jump start, which we see over here, jump start point here, so we can connect that via cables, jump start the vehicle, which is the #1 fault within EVs. And then having a look here, we've also got these cables. So this is our potential equalization cables. So very important safety factor within EVs, where we're actually equalizing any potential energy. So in this case, this would be, for example, if you have a internal fault within the inverter, if someone comes along, say for an example, a mechanic coming along and touches a component and then touches a different part of the vehicle, there's a potential for transfer of energy through the person, obviously with your heart in the middle, which is not a good thing. So all of these vehicles have a potential equalization or bonding, which then obviously, as the name incurs, it equalizes any of this potential across the components. So this is a very important safety factor, and something where we can here also simulate with faulty cables. We can simulate situations that everything is okay or where the cables are defective. We also see here that we have the onboard measuring devices that you're used to from Lucas Oil. So I've got a 4-channel, so mainly used for oscilloscope, but you can also use a voltmeter down there as well. And we've got a HDMI output that we see here. So able to use the display that you see here onto a much larger screen. If we have a look at the various modes within here, we can have the vehicle settings. So we can change the different types of vehicle that we see. So if it's a hybrid vehicle or a fuel cell vehicle, we can switch on smart relays, switch them on or off. We can switch between a hall sensor or a resolver under the vehicle settings. Under the administration settings, we've got a master volume to turn the sound down. We can deactivate the smart key if you lose the smart key. So if just a very quick look, we can see here that there's also, in this case, 2 pages of faults that you can switch on, but there's also quite a lot of hardware faults that we can put in here that we'll see separately as well. Another thing that you can do here also is to switch it between miles per hour, kilometers per hour, just with the flick of the switch, just to help with the various countries around the world as well. So that's a very quick look at what the system can do, what it's set up like, what's the didactical method behind it. And yeah, there'll be many more videos coming out that go into much greater detail about all of the various points.
Thank you, Daniel, very much for this quick wrap up. So if you're now interested and you want more information, just get in touch with us, for example, via email. You see the email address shortly after this video, and we're looking forward to hear from you.